Hi, on page 3 of the notes for 1.6, we're in the section where we're subtracting real numbers, positive and negative numbers, and we're just converting that to an addition, adding the opposite of the second number. So we've made it through the notes. We're now going to look at some of the practice plus examples that you'll see when you do the textbook practice problems. And remember, these are a 2-in-1, a 2-for-1 deal where they're combining some earlier skills with what we're practicing in this section. So as we just take a glance at these two problems that I've picked out, 86 and 88, 86 brings in absolute value. So that's a concept from earlier. 88, however, at first glance, it looks like we've just got fractions. Well, fraction isn't any different than what we did last time. However, there is something in here that is a 2-in-1. You've got the subtracting positive and negative numbers, but you also have the potential for distribution. So at first glance you might go, is this really a practice plus? Is this really 2-in-1? It just feels like more fractions. It actually is a distribution problem, and so we'll look at that when we get to that one. But let's stick here back at number 86 and follow this through here. Just a reminder, as a recall here, we've got absolute value involved. What does that mean? One way to think of it is in terms of distance back to 0 on the number line. Another way to think of it is it takes whatever's inside and makes it positive. Whether it's negative, it becomes positive. It's positive, it stays positive. But the one thing they want to emphasize in this particular time using it is that absolute value can also be used as a grouping symbol. And we hinted at that with, we mentioned it with one of the other examples that we did earlier in a previous section that had absolute value, and I believe it was also a practice plus situation. They work as grouping symbols, so you actually need to deal with what's inside first. You don't apply the distance or making it positive until you actually come up with a single item inside. So inside the absolute value. So right now we've got 8 minus a negative 2, plus we have a negative out front here. We've got a minus a negative 6. We've got a lot going on. So as always with practice plus, you want to breathe nice and deep and take it one little bit at a time. And another thing we're trying to emphasize is when you see a negative out front, it's as if it's -1 times that item. So it's like a -1 times that absolute value. Then you're going to be subtracting a negative 6. Notice also the instructions here. It says to find the value of each expression. There's no equal sign here, but notice it's not an algebraic expression. There's no variables going on here, and we actually will expect to find a final answer of value. So you can expect a final answer when they say to find the value of something. So the directions give you lots of clues how to start, what you can expect to see at the end. So it's a real valuable tool to pause and read those instructions and interpret what they're saying. Okay, so as a grouping symbol there in the in those absolute value bars, kind of look like rulers. That's the way I remember that we need to come up with a positive distance back to 0. We've got an 8 minus a negative 2. So in that case, I'm going to add the positive here. So this is going to become adding a positive 2. Okay, so I add the opposite. That's my first step here. And this is really positive 8 that's inside of there. There's still things happening inside the absolute value. So treating it as a grouping symbol here, I'm still going to simplify this into what's happening inside that absolute value. So everything else I just copy. Negative out front of something is like saying -1 times. So -1 times the absolute value minus a negative 6. And same sign, so I add them together. 8 plus 2 is 10. I keep the bigger sign. It's positive. So I've got -1 times the absolute value of 10 and then minus a negative 6 here. So absolute value of positive 10 just keeps it positive, so it becomes 10. I still have the negative 1 times that minus a negative 6, okay? So it's the negative of the absolute value. It's the negative of what we came up as a result of the absolute value. It's a negative 1 times that. So the negative out front will turn whatever the absolute value is, which is always positive, back to that negative. So the negative 1 times 10 is negative 10. Order of operations said we had to deal with that multiplication first. And then we still have the minus negative 6. Doing our, now this is back to the very beginning of this section. We're subtracting positive and negative numbers. So I'm going to make this add the opposite. So it's negative 10 plus a positive 6. Our signs are different, negative and positive. So 10 minus 6 is 4. Keep the sign of the bigger number. Our final value here is a negative 4. Let's look at number 88. I hinted at this so that I could kind of plant the seed. I'm utilizing what I always tell you guys, that we're connecting new information to old. So this can be a fairly new concept here, so I wanted to plant the seed, work on something else, and let your brain kind of file it away. We're going to come back to it here. And here's what I said earlier. At first glance, knowing we're in the Practice Plus section, expecting that we're working on 2 skills in one problem. We had absolute value and subtracting positive and negative numbers in the first one. I look at this and I don't see the second skill. I only see subtracting fractions, subtracting positive and negative fractions. Now, you could think of it as, well, it's fractions, but we just did problems with fractions already in this section. So where's the 2 and 1? What's the second skill? And it goes back to what we did at the beginning of this problem over here in number 86. We talked about the negative in front of something is really negative 1 times that. So the negative outside the absolute value is going to make that final answer negative, or the opposite of what comes out. So it's like negative 1 times that. Well, let's apply that to this situation right here. Let's change the subtraction to addition like we've been used to. So 9/10 plus the negative of this parentheses. Okay, so we've got a negative out front here. This is not the only way to do this problem, by the way. You could just go straight through order of operations. So what I'm doing now is I'm going to look at distributing that negative in front of the parentheses. Let's do that. That's in front of the parentheses. Okay. Or you could use order of operations from the beginning, okay, where inside the parentheses, find the least common denominator, subtract, which means you add the opposite. Then once you get your answer here, you have 2 fractions, you have subtraction, you'll add the opposite of whatever you get inside here. Then again, least common denominator. So what I'm trying to do here is 2 things. 1, show you a concept, but 2, in the back of my mind I'm thinking, I see matching denominators of 9/10 and 7/10. Wouldn't it be nice to get those together and deal with those first? But I can't just start moving things around because I've got all subtraction here. I need all addition, and I've got these silly parentheses that are in the way. They're already being grouped, but I can't ungroup them because I've still got all subtraction here. I need all addition. So that's what I'm attempting to do. I'm attempting to get the tenths, the ones that are already have the matching denominator, together next to each other so I can deal with those first, and then only have to do 1 least common denominator. As a bonus, what we're getting is exposure to this idea. How do you deal with a negative in front of parentheses? You get to distribute it. Okay, so 9/10 plus, it's like having a negative 1 times. We have a negative out front of a grouping or parentheses. It's like having a negative 1 times that. You get 1/4 minus 7/10. What does that mean? That means that negative applies to both pieces. It means you're finding the opposite of both of those. Now we're skipping a little bit ahead because this is really multiplying positive and negative numbers, which we'll officially cover in 1.7. But for most of you, you've been exposed to it. So again, I'm just showing you one way to do this problem. If you came up with the correct answer in a different way, I'm totally okay with that as long as the way makes sense to you and it's consistent for you. Okay, you didn't just close your eyes and hope for the best, right? So when we distribute this -1, okay, let's talk through this again. I looked at this, and knowing I'm in Practice Plus, I know there's two different things going on here. Aside from that, I'm looking at this going, I wish those 10s were next to each other, but I've got subtraction in the way, and I've got these parentheses in the way. I cannot move the parentheses because I've got subtraction going on. I cannot switch things around because both the subtraction and the parentheses. So my goal here would be to get rid of the parentheses. And when I've got just a plain old negative in front, it's as if I had a -1 in front, and I can distribute to get rid of the parentheses. I can multiply that negative across both. Taking the negative of something is really saying you're taking the opposite of something. Okay? So you get the opposite of all these. So you end up with, and I'm going to kind of squeeze this together here. Maybe I'll give myself some more space. I'm going to end up with 9/10 plus a -1/4 plus a, now look at this here. I need to fix this first. I've got subtraction of a 7/10, so I'm really adding that -7/10. I'm really adding that -7/10. Really adding that -7/10. So now I'm finding the opposite of that -7/10. So the plus comes here. The adding, I'm finding the opposite. Whoops, this is still a negative. Sorry. Finding the opposite of the -7/10. -1 times that becomes a +7/10. Okay, what I've done here is I've eliminated the parentheses using distribution. I've got subtraction here. Another way to think of it is I subtracted both of those pieces. I subtracted the 1/4, which becomes really adding a -1/4. I subtracted the -7/10, which is really becoming an adding +7/10. So many different ways to think about this and talk this one through. Find the way that makes the most sense to you. And I'm happy to go over this again in class because this one is pretty heavy duty. Now what I've got here is I've got all addition, and that lets me regroup and reassociate. So I can rewrite this as 9/10 plus 7/10 plus a -1/4. And what that gets me to here is these already have common denominators. 9/10 and 7/10, that's 16/10 plus a -1/4. No need to reduce yet. We'll just go ahead and get to least common denominators. To be able to add these two fractions together, I need common denominators. So the least one that they both have in common is 20. So 16/10 becomes 32/20. Again, I'm assuming that fractions are coming together for you. If they're not, please get some help right away. Get that extra tutoring, extra practice that you need. Because we're going to treat, in Math 60, we treat you as if you've got fractions under control. And we then start working with the algebra involved with that. Converting -1/4, this is going to become a -5/20. Now we have like denominators. We are adding different signs. We've got positive and negative, so we subtract. 32 minus 5 is 27/20. Keep the bigger sign. You get a +27/20. Or you could write that as 1 and 7/20. I'll accept either of those as the correct answer. Okay, so take a moment to copy what you see, talk it through to somebody. Again, knowing this is Practice Plus, and as we go through this course, there's multiple ways to do different problems, multiple ways to think it through. So if the way I described it, using distribution, didn't quite settle right, or you would have done it a different way, and you tried it and you still got the same answer, great. If you're unsure at all, just run it by me and I'll let you know, yeah, that method will work every time. Or, oops, you got lucky, here's why, because these particular numbers, made it work for you. But most of the time, students are, apply the rules correctly and you come up with a way, and then I get to learn a new way to do it too. So I would love to have that conversation with you. All right, we're going to move on to translating now at the bottom of the page.